I welcome you all to the Spark Research YouTube channel. This is Dr. V. Chandra, Assistant Professor in the Department of ECE. In this series, we are running in this course Analog and Digital Communication. So this is the part second of this series of this unit second. However, this is the another part second. We are going to consider the two sessions. So this is part A. So we will continue to talk about the analog modulation techniques. So if you remember, in our previous session, we have discussed the amplitude modulation, and in this session, we are going to talk about the frequency modulation. Right. Also, we'll see the types of frequency modulation and the narrow band, your wide band, and generation of NBFM, and the remaining parts will continue to talk in the another session. Right. Okay, so first thing is that what is this frequency modulation? So if you remember in our previous session, we have discussed the amplitude modulation. So in amplitude modulation, we have varied the amplitude of the carrier wave, right? Now here, suppose this is the message signal and this is your carrier wave. So what is the difference in between message signal and a carrier wave? So message signals have the very less frequency and this is your carrier wave which have the very high frequency. You can observe it, right? What is the frequency range? So normally the frequency of your message signals may fall in the range of 100 300 hertz, and for carrier it may be in the kilohertz, megahertz, and even the gigahertz, right? Now question is that how your carrier wave will vary, means this message signal modulated, that is also called the modulating signal, this only have the information, right? So this have the message information, but carrier wave doesn't carry any information, right? So only thing is that carrier wave can transmit to longer distance because of its frequency, and then the message signals can be loaded in this carrier wave. So if message signals will be loaded to the carrier wave, then that is called the modulated wave. And since here we are going to load the message information by varying the carrier, by varying the frequency of the carrier, so that is why this is called frequency modulated signal. So if you'll observe, try to observe, then here the peak of your modulated signal, that is message signal, is maximum. So here you can see the frequency is maximum, and then here it is minimum. So here the frequency is also minimum. So frequency of the message of your modulated wave will vary with respect to the message signal. So this is a way to modulate the frequency modulation, right? So this is the pictorial view. Now mathematical point of view, if you remember in amplitude modulation, then the amplitude of modulated wave, that is VC, is varying with respect to the amplitude of modulating signal, that is message signal, right? But here see, here angle will vary, right? So amplitude is same, what angle, MC omega t n plus something, right? So angle is going to vary, so that is why this is called the frequency modulation. If frequency is varying, right, and if phase is varying, then that will called as the phase modulation. So angle modulation can be divided into the two parts, frequency modulation and phase modulation. Okay, so here why is this term, you may think. So this is basically the integration over Vm of cos of omega t. So this part will be the integration. So finally, actually this will be your final frequency modulated wave, right? So frequency modulation can be defined as the process by which the frequency of carrier wave is altered in accordance with the instantaneous amplitude, right? So how can we write the instantaneous amplitude? So that is the challenge, right? So because here theta is going to vary, so this angle in tan term, so how can we write? Because if your angle is varying, you know, the from t is equal to 0 to infinity, then this is the challenge to write the equation, right? Why? Because there is no fixed angle. So that is why the new concept has introduced, that is instantaneous angle. So theta t will be minus infinity to t and integration, then omega ct plus k of mf, right? And so here m of alpha may be the your cosine function, vm and cos of omega t. So you can integrate and you will get, and then after that you can replace and you will get the final fm signal, right? So this is your final fm signal and this is both are same only. So here the example is your empty signals is your cosine function. Okay. Okay, so now if you remember, then the problem is that uh, in your frequency modulation technique, so since your frequency is varying, so it is difficult to find out the bandwidth, right? Since frequency itself is varying, so how can we find out the bandwidth? So this is the one of the challenge. So if frequency is varying little bit, right, in that case that is called the narrow band. And if frequency is varying very large, here this figure is not very much accurate, large frequency here, the frequency should be very large and high, gap less and high. In that case that will be called as the wideband frequency modulation. So the main point is that if your modulated carrier modulated frequency modulation may have a variation, that large variation in frequency, the a small variation that is your narrow band and large variation that is wide. Okay, so fm signals can be given by like st is equal to this a cos omega ct plus beta of sine omega t, right? So based on value of the beta, if beta is very small then it is called narrow band, and beta is very high, that is called the wide band. And this function, the cosine function, can also be written as like 1 plus k of at and minus of k square, this term. If you remember the previous slide, then we have find out the phi, that is a modulated frequency modulated wave. So that can also be written as like this, right? So now question is that why are we writing like this? Because our target is to find out the bandwidth. So in order to find out the bandwidth of the narrow band and frequency modulation, we are going to use this particular equation. So we'll use only 1, 2, 3 parts, and the remaining will have the very high frequency. So right, we are going to neglect. So narrow band angle modulation. So like unlike amplitude modulation, here your superposition principle will not be valid. Cos A plus B is equal not equal to A cos the and plus A cos B. So that is why your principle this will not valid here. So phi of that is your final frequency modulations. If it is very less, your beta is very less. That is k of A of t is very less than 1. In that case, it will be your A of cos of omega ct minus kf at and sin omega t. So this is almost equivalent to the amplitude modulation. And similarly for phase modulation, your equation will be A cos omega ct minus kp mt and sin of omega ct. But these equations will be valid only for narrow band, means the frequency deviation is little bit. Otherwise, it won't be valid. Now, another question is that how can we find out the bandwidth of frequency modulation? Why is this question? Question is because the frequency is varying in frequency modulation. So how can we find out the bandwidth, right? Bandwidth means what? The difference of the upper frequency to lower frequency. So that is the challenge. So that is why the concept we are talking about the instantaneous frequency. So first we will find out the instantaneous frequency and then we will approximate the bandwidth, right? So for narrow bandwidth, this is almost equal to the twice of B, that is the bandwidth equivalent to the amplitude modulation, right? For in general case, you can use this Carson's rule in order to find out the bandwidth of the frequency modulation. That will be equal to a beta fm equal to twice of b beta plus 1, where beta is equal to del f divided by b. So this is one of the very important equation. So with the help of the Carson's rule, uh, it is very easy to find out the bandwidth of a frequency modulated wave. If it is only narrow band, in that case, no need to find. Simply, you can use twice of beta, that is twice of b, that is the double of your bandwidth, because this will simply same similar to the amplitude modulation case, right? Now, generation of narrow band frequency modulation. Since narrowband frequency modulation is very similar to your amplitude modulation, so we are going to use your DSB-SC modulator here only, right? So MT is your message signal and here is your carrier wave. So carrier wave, and use the Hilbert transform, that is shift your angle by pi by 2. So cosine will turns into the sine and then pass through the DSB-SC modulator. DSB-SC modulator we have already discussed. This is multiplier only, so it will multiply and then finally add, and you will get the frequency a phase modulation, right? And in order to get the phase modulation, just integrate your m of t and then pass it with the same process, so you will get the narrowband frequency modulation. Right. So in order to get the narrowband frequency modulations, only thing that you should remember that in case of frequency modulation, integrate your mt, that is message signal, and in case of phase modulation, no need to integrate, simply use your amplitude modulation technique, right? That is DSB-SC modulator, and you will get the narrowband frequency modulation or phase modulation, right? So here is the circuit exactly, that is how can we get the exactly here. So here is your modulated amplitude frequency modulated wave, and here is your diode which will vary. Because of that, this diode only, what will happen, your frequency will vary. And here is your tuned oscillator, so this will help, right? So the varactor diode is reverse biased by negative DC source, that is minus VB here. The modulating AF, the voltage appears in series with the negative supply voltage. Hence the voltage applied across the varactor diode varies in the proportional with the modulating wave. That is how the varactor diode appears in the parallel with the oscillator tuned circuit. Hence the oscillator frequency will change with the change in the varactor diode capacitance, and frequency modulated wave is produced, right? So this is exactly way. So that's all in this session. We will cover the remaining portion in the another session. Thank you to join. If you have any doubts, please drop your comments.